Okay, good afternoon, geometry honors students. So today I would like to talk about that section's hypotenuse and leg. So this one is actually part of the Unit 5, Chapter 5 from the big idea, but somehow that it's missing right there. Hypotenuse and leg, that's another postulate, so which we can use to prove the triangle's congruent. So anytime that we deal with the right triangle, like triangle ACB, triangle DFE, so in order to prove those two triangles congruent, all you have to do is just showing that the hypotenuse, they're considered congruent, okay? And also one of the leg, so showing that they're congruent as well. If the hypotenuse and the leg of one triangle are congruent to the corresponding part of the other triangle, then those two right triangles must be congruent. Okay, so like this one right here, given segment AB, it's perpendicular to segment BD. So perpendicular, what that implies is it makes 90-degree angle. So CD is perpendicular to BD, another 90-degree angle. So that means segment AD is congruent to CB. Well, that's another given. So AD is congruent to CB. So in order to prove that the triangle is congruent, so we need to start it off with the right triangle first. Okay, so let's start it off with statements and reasons. Okay, so statement, reason. So again, the given, it's all about the written statement, the one that we just went over here. Okay, so all the perpendicular line segments. And also you want to say that AD is congruent to CB. So it's all given. And then the next thing that you want to state here is that angle ABD, it's congruent to angle CDB. So basically what this one does, it shows that the right triangle. Okay, so CDB. So this one is by using definition of perpendicularity. And also congruent angle, 90 degree. So now the another thing that we can show here is that segment AD, well, it's already given here, so segment AD is congruent to segment CP. So we don't need that right here. So otherwise that would be duplicated. So here's one thing that I want to show is that the BD, the leg right here, so the bottom base, so segment BD, it's congruent to segment BD. And this one is by using the reflexive properties of equality. And then continue with that statements and reason. So therefore triangle ABD is congruent to triangle CBD. And the reason why that is because this one is by using hypotenuse and leg. Okay, so this one is a 4-step proof. And now what about the one that involved with a circle and then like a 2 tangent line going through and the radii? Okay, so let's look at that. So again, statement and reasons. So started off with YO, it's perpendicular to YX. ZO is perpendicular to ZX. Okay, so perpendicular. And the other thing that we notice, the leg right here, or the hypotenuse for those two triangles. So let's say this one, we just want to extend the line all the way through. So let's say that OX right there is the auxiliary line. Okay, segment OX is congruent to OX. So this one by using the reflexive properties of equality. Okay, so another thing that you want to state next is that the 90-degree angle. Okay, so the 90-degree angle. So it's perpendicular. So that means angle OYX is congruent to angle OZX. And they're both considered 90 degree. Again, definition of perpendicularity. And then after that, also the radii, segment OY is congruent to segment OZ. And this one you just want to say that it's a definition of radii, or definition of radius of a circle, or definition of radii. So whatever the radius that you put in here, so they're always the same, because that's within the same circle. And then therefore, so triangle OYX is congruent to triangle OZX. Hypotenuse and leg. And then finally, the final statement. And you want to say that segment YX is congruent to segment ZX. And this one is by using CPCTC. Okay. So here's another one. Given that angle A is greater than angle C, find the restriction of the value of x. So one thing that we notice, angle A is greater than angle C. So that means the corresponding segments, okay, so all the corresponding segments, they also have the same kind of relationship. So this one is by the Hinge Theorem. So what Hinge Theorem is saying that if angle A is greater than angle C, that means the corresponding segment, so which is what? Segment BC must be greater than segment AB. So what this one is showing that 5 minus x is greater than 5x plus 10. But the things that you want to find the restriction. Okay, so the restrictions. So we need to set up another inequality for this. Well, let's just solve for x for this one first. So this one, subtract 5x on both sides. So we got negative 6x. Greater than, subtract 5. So we do have 5 right here. Divided by negative 6. So that means x is less than 5 over 6. 5 over negative 6. Or negative 5 over 6. It's just the variable. So another thing that we notice, because this one is the line segment, so that means 5 minus x must be greater than 0. Or 5x plus 10 must be greater than 0. Okay, so that means 5, it's greater than x. So that means x is less than 5. But what about the other one here? So 5x plus 10 is greater than 0. So that means 5x must be greater than negative 10. So for that one, so that means x must be greater than negative 2. Okay. So now let's find out the boundary. So this one got to be greater than negative 2. And this one is showing that x could be less than 5. Okay. And this one must be less than negative 5 over 6. Okay. So that means the boundary, it got to be right between negative 2 and negative 5 over 6. Okay, so it must be greater than negative 2, but it's less than negative 5 over 6. Again, the reason why that I said the line segment greater than 0, because that's a measure of the length. The length cannot be negative number, cannot be 0. So it must be greater than 0. It's a positive number. Okay, so that's it. So thank you for watching the video today. So I'll see you guys next time.